Hello. So, been 2 or 3 years ago, but had a conversation with someone and mentioned that somehow helium came up, and the mention that supplies were running low. It's more expensive to buy helium, stuff like that. And so, you know, here we are a few years later, and I decided to start looking up stuff about helium. Actually, I started thinking about helium back then, and I just sort of completed my research more recently. So I thought I'd share some facts about helium. So, I mean, we most of us know, we put helium in balloons, and yay, they float. Um, there are several other uses for helium. So, used as a coolant. Um, the CERN Super Collider for particle physics, they use liquid helium to cool um, their device uses a lot of magnets, and these heat up with high energy physics. It's going to heat up, and so they have to use liquid helium as a coolant. Helium liquefies at around 4 degrees Kelvin, which is around minus 269 Celsius or minus 452 Fahrenheit. So liquid helium is actually one of the coldest substances that man creates or can create, um, or that we use at least. I don't know if we've ever tried to create things more cold than this. Also, so pebble bed reactors, which is the next generation of nuclear reactor, are designed to use helium as a coolant. They don't use liquid helium, but in a gas form, helium can be kept at a much cooler temperature than other gases. Well, MRI machines, magnetic resonance imaging that hospitals use helium to cool. Again, they're the magnets within the machine that uses helium to cool those. And then there are helium-filled hard drives. Also use it as a coolant as opposed to just normal hard drives. So these are for specialized computers. You can't just buy these at your local computer store. This is like something the government would use. Um, Helium is also chemically stable or electrically stable, so it's used for things like cleaning rocket tanks and arc welding, used as a shield for arc welding. Helium and argon are both inert gases, so it's a helium-argon mix used for the arc welding shields. And this, again, just to protect people from electricity, protect them from, like I said, cleaning rocket tanks. You're using very volatile substances to make the rocket fuel. So when you clean the tanks out, you want to use a very inert substance, and helium works well for that. Other manufacturing for fiber optics, it's used to prevent bubbles from getting in the cables. Also for other semiconductor manufacturing, so all your cell phones and tablets and other stuff, helium is used partly in the making of that. Then the last two are helium. It flows well, and so airbags, your car airbags, use helium in them too, so they can deploy quicker because the airflow, it's not pure helium, but it will help your airbags to deploy quicker. And emphysema treatment, they mix oxygen with helium in order, again, to allow the oxygen, the gas flows better, so the oxygen helium mix can get to the patient quicker. So people have emphysema or asthma will sometimes be treated with a helium oxygen mix. Now, along these lines, we all know that if you breathe helium, your voice gets higher. That said, you shouldn't breathe helium too often because while it is used in a mix for treating emphysema, it will also displace oxygen. So if you're breathing pure helium, it'll displace the oxygen in your lungs, and over time, if you do it too often, you can die. Um, unlike other gases, like the helium's a light gas, unlike other gases, it is easier to clear out of your lungs if you get it. So, if you start to feel lightheaded or something after breathing helium, it's just a matter of just doing some forced exhaling to clear your lungs, and then making sure you breathe some pure air, or oxygenated air, just to make sure. So it's not really a super deadly thing unless you overdo it. Now that said, Big Bang Theory. There was an episode where Sheldon was doing a phone interview. So there's like interview for the radio, but they called him up and they were doing it over the phone. And Barry Kripke started pumping helium into his office. And so throughout the interview, Sheldon's voice is getting higher. And so the question is, if you're filling the office with enough helium to start affecting his voice, shouldn't he be dying? And the answer is maybe, maybe not. The good news is when he does pass out, helium rises, so he's falling into the lower, if he does pass out, he would fall onto the floor where there is more, non-heliumated air, if you can call it that. Fourth Doctor, Doctor Who. There was an episode, The Robots of Death, where the bad guy was controlling the robots through voice recognition software, basically. They didn't call it that back then, but that's basically what it was. So the Doctor flooded the room with helium, changed the guy's voice, the robots didn't recognize him, and they attacked him. To flood the room with helium, he had his assistant Leela hiding in a cabinet with the helium tank. Smaller space than Sheldon's office on The Big Bang Theory, so if enough helium is getting into the room to cause the bad guy's voice to change, then this cabinet that she's hiding in is probably flooded with it, and she's probably dead. So, sorry, I liked Leela as a sidekick, but she should have died in that episode. Anyway, so how does this work? While we're on the subject, is sound travels at different speed through different substances. And so I think in helium it moves. Helium is about 6 times, or about 1/6 as dense as normal air, which doesn't necessarily translate into moving 6 times as fast, but it does mean it will move faster. Because it's moving faster, the wavelength of the sound appears to be shorter. It's basically the wavelengths are hitting faster, and shorter wavelength means higher pitch. So that's how helium makes your voice sound higher. That said, you don't necessarily need it to be filled in your lungs. You just need to get into space around your vocal cords and in your mouth. So you don't really have to deeply inhale helium to change your voice. You can sustain the effect longer if you inhale the helium, but you don't have to. So where does helium come from, now that we've gone through all that? So in 1860, Gustav Kirchhoff and Robert Bunsen invented the spectrometer, or spectroscope. And it's a means of analyzing light. And we found out things like, different elements give off different spectral lines, so we can, analyze things, chemicals with lights, whatever lines come off tell us what elements are in it, or what atoms are in it. So they did that. That was 1860. August 18th, 1868. Pierre Janssen, a French astronomer, is using a spectroscope to observe a eclipse of the sun. And he notices there's this yellow spectral line that no one expected to see, or it doesn't show up in any books or charts about spectroscopy at the time. So he speculated this was another element, or a new element. A few months later, on October, where is that? 20th, 1868. A man named Joseph Norman Lockyer was observing the sun through a spectroscope, saw the same thing, made the same conclusion. His wife Winifred was working with him. She often validated his observations, basically eyewitness account. There was a chemist named, what was his name? Edward Franklin working with him also. So wrote a paper on it. Now, due to the mail system and like I said, Janssen was observing in India because he went to observe the eclipse. Lockyer was just observing in London. Most scientific papers were sent to Paris at this time, so due to the nature of the postal system and especially international postal rates, or back in the 1860s, were not that great. So both their papers got to the Paris Institute, which normally sort of specialized in these things, on the same day. So Janssen discovered it first, but their papers didn't get in until the same day. For some reason, which I couldn't find out, Franklin decided he didn't want to co-author. I don't know if him and Lockyer had a fight, or he just didn't agree with his conclusions or whatever, but even though he worked to discover helium with Lockyer, he decided he didn't want to be associated with it for some reason. And again, I couldn't find out why. So, like I said, the Paris Institute got both papers on the same day, and so it credited both men with the discovery, even though Janssen discovered it first. Interesting side story about Janssen. So he was in Paris in 1870 during the siege of Paris. The French and the Prussians were at war, and there is a story of him escaping Paris by a hot air balloon, which it's a true story, but it is not 100% accurate in the way most people sell it. So first off, we should note that he didn't have to escape. The Prussians, they knew he was there. He was planning on going to Algeria to observe another eclipse. This was well-known fact. The Prussians knew he was planning on doing this. And they thought, science was more important than war at the time, or his contribution to science wasn't reason to keep him prisoner. So they sent a note to him. Paris was under siege, and they sent a note to him and said, "We'll let you leave. You can go ahead, go to Algeria, do your work, says you're not a threat to us." And he wrote back and said, "No, I'm going to escape the city in a hot air balloon." So the first thing is, he didn't have to escape. He could have left on his own if he wanted to. They threatened to shoot his balloon down. He did make it out. This was when was this? This was December 22nd, 1870. And on the 23rd and 24th, the Battle of Helium was fought between the Germans and the French, which is basically, they'd had Paris under siege, now they tried to take it over. So that was the first thing. The second thing is, most people hear, the discoverer of helium escaped in a hot air balloon, and they assume it was a helium balloon, and it wasn't. It was just a hot air balloon, standard to the times, because helium, like I said, it had been discovered in the sun. It wasn't discovered on Earth, or wasn't isolated on Earth for another 15 years after the Battle of Helium. William Ramsay isolated it. He was treating cleveite with acid and separated helium from it. He actually sent a sample of this to Lockyer. Cleveite is a uranium ore found in Norway. Now, at about the same time, a few days after this, or a few months after this, not sure exactly how long, a man named, what was his name? Abraham Langlet, a Swedish chemist, did the same thing. And again, so this is one of those situations where independent scientists come up with a discovery at almost the same time. It is known that Ramsay did do it first, but Langlet, he did do a little more work with it. He accurately determined the atomic mass and other stuff, which is important to chemists, so he still gets some recognition. Speaking of independent researchers just making discoveries, Lockyer and Janssen did meet. And they did become friends. There wasn't a big competition. They recognized, yes, we were doing similar research. We didn't steal each other's research. And just the idea of sharing the discovery, weren't in big competition with it. They became friends after this, which is sort of rare, especially if you look at some modern scientists, the way they behave. They were perfectly fine sharing credit for discovering it, even though Janssen was clearly discovered it earlier. Anyway, so Ramsay isolated it, like I said, by treating cleveite with acid. It can also be isolated from, what are these called? Pitchblende and monazite. Pitchblende is another ore, a uranium ore. Monazite is a thorium ore. And I bring this up because thorium and uranium are both alpha emitters. They're radioactive materials. They emit alpha particles. An alpha particle is, if you look up old textbooks, they will say it is a helium nucleus. It's basically 2 protons, 2 neutrons. And that is how we, like I said, up till now it's mostly been discovered in the sun. Now we're finding, it is on the Earth. And how it got on the Earth is basically alpha decay of radioactive nuclides. Uranium or thorium gives off an alpha particle. It captures 2 electrons. It becomes a helium isotope, or not isotope. Well, yes, helium atom. It'll be the isotope will be helium-4. It was in 1905, actually December 7th, 1905. Hamilton Cady and David McFarland were analyzing natural gas, and they found helium in it. And so this is where, again, most of the helium we get today, even though, like I said, Ramsay and Lockyer showed that we can manufacture it in other ways. What we found out, it's in natural gas, and that's because most natural gas deposits are in areas which have some sort of alpha emitter in it. So not that gas is filled with uranium or thorium, but the rock structures that it's located in usually. Granite has a lot of thorium in it. So the thorium gives off alpha emission, captures a couple electrons, becomes helium. It gets trapped in a pocket underground somewhere. And so that's where we get it from, is we actually mine helium. We there are these gas deposits of it underground. And so we don't just make it, we actually mine it, and we, it needs some purification and stuff when we get it out, but it's still, it's a result of being emitted from uranium or thorium. Now, even though it comes from a radioactive isotope, it itself is not, or at least naturally occurring helium is not. So well over 99%, 99.999863% of the helium on Earth is helium-4, which is, like I said, it's one of these deals where it's captured and, it's been emitted from a uranium or thorium, and then it captured some electrons. 0.000137% of helium on Earth is helium-3. Not 100% sure where that comes from. Both of those are radioactively stable. There are several unstable. These are all man-made. They aren't naturally occurring. Thing is, they're really not a threat because they have very short half-lives. So the longest half-life, the most stable of these, is helium-6 with an 807 millisecond half-life. So that would be 0.000807 seconds. So it's very short. The most unstable measurable one is helium-5, which is 7 times 10 to the minus 22 seconds, or 0. Then you list 21 zeros and then 7 seconds. So it's extremely short. There is also helium-9, which is only listed as very short, its half-life. So I don't know if that is so short that it can't be measured, or it's that we just haven't generated enough helium-9 to determine how short its half-life is. So like I said, it's radioactive helium can exist. It just doesn't exist for long when it does, and we have to make it to exist. So that said, price of helium is going up. That's how the original conversation that got me started on all this got going. It's basically we're depleting our supply of helium. Helium is listed as a non-renewable resource. Technically, as long as we have thorium and uranium, it will continue to renew. It's just we are using it up a lot faster than we can renew it, so it's considered non-renewable. So we had this conversation about how we were using up all the helium, and I made the joke. So when we use up all, helium makes things float. So when we drain all the helium from the Earth, it's going to fall out of the sky. And some of the people there, no one realized I was joking, and so most of the people looked at me like this guy doesn't know science, because he didn't recognize it as a joke. And one person looked at me like they were panicked that, oh no, we only have 20 years before the Earth falls out of the sky. And so I'm not sure, like I said, it's sort of amazing that none of them knew I was joking. And it's even more amazing that one of the people apparently took me serious that the Earth was going to fall out of the sky in 20 years. Because that's about, current usage, they estimate we got about 20 years of helium left. And that's all. Lockyer, before I forget, he named helium after Helios, the god of the sun, because he observed into the sun. That's where the name comes from. And that's it. Have a nice day, and don't breathe helium.